In 2007, Nokia controlled 40% of the global smartphone market. 3 years later, they were irrelevant. The mistake they made was not a bad product. It was failing to see where the battleground was shifting. Today, the same shift is happening in AI infrastructure, and Elon Musk is betting everything that the battleground is about to move somewhere no one expected: outer space. In this video, we are going to do three things. First, we will look at why Earth-based AI infrastructure is hitting a wall, and why that wall is arriving faster than anyone predicted. Second, we will break down Elon's actual plan: Terafab, the orbital constellation, and the economics behind it. And third, and this is where it gets complicated, we will examine why some of the world's top scientists are calling this idea either the most important project in human history or the most reckless. Let's start with the problem. Earth is running out of room. To understand why anyone would seriously consider building data centers in space, you first need to understand what's happening on the ground. AI is hungry. Insatiably, almost incomprehensibly hungry for electricity. A single query to ChatGPT consumes roughly 10 times the energy of a Google search. Multiply that by billions of queries per day, and you start to understand the scale of what's coming. Goldman Sachs projected that AI data centers will consume 8% of total US electricity by 2030. In 2022, that figure was 3%. But electricity is only half the problem. The other half is water. Modern data centers cool their servers using water, millions of gallons of it per year. Microsoft's data centers consumed 6.4 billion liters of fresh water in 2022 alone. Google's figure was similar. And then there's land. Finding sites for new data centers that have access to cheap power, reliable water, and political stability is becoming genuinely difficult. The NIMBY effect, communities blocking new data center construction, is accelerating. The grid cost is already being passed to consumers. In some states, electricity bills have risen 10 to 15% in the past 2 years, partly attributed to data center demand. So here's the constraint. AI is growing exponentially. The infrastructure supporting it is growing linearly. Something has to give. And Elon Musk's answer to that constraint is simple: go up. But before we get to the orbital plan, I want to share something that changes the entire framing of this conversation. Because while most people are treating this as Elon's latest moonshot fantasy, no pun intended, a Y Combinator-backed startup quietly launched a working prototype into orbit last year. We will get to that, but keep it in mind. Terafab and the orbital bet. Elon's vision operates on two levels. There's the Earth-side piece, and then there's the orbital piece. You need both to make this work. On the ground, Elon has announced what he's calling Terafab, a $25 billion AI chip manufacturing facility in Austin, Texas. This is the foundation. Terafab is designed to produce two specialized types of chips: one optimized for the physics of orbit, radiation hardening, extreme temperature cycling, and one for the raw computational demands of frontier AI. It is, in his words, the most advanced semiconductor manufacturing facility ever built. Now here's where it gets interesting. The orbital piece isn't just put some servers in a rocket. The plan calls for a constellation of up to 1 million small AI satellites, each one roughly the size of a compact car, operating in low Earth orbit. Why does space solve the problems we just described? 3 reasons. First, energy. In low Earth orbit, a solar panel receives roughly 8 times more solar energy per unit area than the same panel on Earth's surface. No atmosphere filtering it. No night cycle interrupting it the way we experience it on the ground. Continuous, abundant, free power. Second, cooling. This one surprises people. Space is cold. 2.7 Kelvin, or nearly minus 270 degrees Celsius. Heat from servers can be radiated directly into the void using simple radiator panels. No water, no cooling towers, no infrastructure. Physics does the work for you. Third, land. There is no land constraint in orbit. You can scale to almost any size, limited only by launch capacity and cost. And that brings us to the single variable that determines whether this entire plan is genius or delusion: the cost of getting things to orbit. Right now, a kilogram of payload costs roughly $1,500 to reach low Earth orbit via SpaceX's Falcon 9. That's already a 90% reduction from what it cost in the 1990s. But Elon's projections for Starship, his next-generation rocket, target $100 per kilogram, or lower. If Starship delivers on that number, the economics of orbital data centers don't just become viable. They become competitive with Earth-based infrastructure. It is already happening. Here's what most coverage of this story gets wrong. It treats orbital AI compute as a future concept. It isn't. It's already begun. StarCloud, a startup backed by Y Combinator, the same accelerator that launched Airbnb, Dropbox, and Stripe, made history in late 2024 by launching a satellite carrying an Nvidia H100 GPU into orbit. The H100 is one of the most powerful AI chips in existence, and for the first time in history, it was running in space. Their co-founders explained the core thesis clearly. We are not trying to replace data centers on Earth. We are trying to serve the demand that Earth cannot serve. Demand that is growing so fast that even with every planned data center built, projections show a compute shortfall by the end of this decade. Their demonstration satellite proved that an H100 can survive launch, operate in the radiation environment of low Earth orbit, and transmit usable compute back to Earth. It is a proof of concept, but it is a working proof of concept. And this is precisely the dynamic that makes Elon's vision credible, in a way it wouldn't have been 5 years ago. It's not just one billionaire's ambition. It's a market signal. When Y Combinator starts funding orbital compute startups, it means the smartest investors in Silicon Valley believe this transition is real. The question is no longer whether this will happen. The question is at what cost and to whom. The part nobody is talking about. And that brings us to the part of this story that isn't getting enough attention. Astronomers are alarmed, not theoretically alarmed, actively, urgently alarmed. The International Astronomical Union has formally warned that a constellation of 1 million satellites would fundamentally alter humanity's view of the night sky. At any given moment, thousands of these objects would be visible to the naked eye, moving, blinking, reflecting sunlight, indistinguishable from stars to the casual observer. For professional observatories, the impact is more severe. Optical telescopes, including those searching for near-Earth asteroids that could threaten our planet, would have their fields of view interrupted repeatedly by satellite trails. Some researchers have estimated that certain scientific programs would become effectively impossible. There's also a risk that gets discussed even less: Kessler syndrome. In 1978, NASA scientist Donald Kessler proposed a scenario in which the density of objects in low Earth orbit becomes so high that collisions generate debris, which causes more collisions, which generates more debris. A cascade that could render certain orbital bands unusable for generations. We have never operated with 1 million objects in low Earth orbit simultaneously. We do not know with certainty how to manage that safely. And then there's the geopolitical question. Who governs orbital infrastructure? If Elon's constellation becomes critical AI infrastructure for governments and corporations worldwide, who has jurisdiction? Who controls access? Who decides what gets computed? And for whom? These are not hypothetical concerns. They are the same questions we failed to answer about social media in 2010 and are still dealing with today. To be fair, proponents have responses to each of these concerns. Starlink satellites are already being redesigned with lower reflectivity coatings. Orbital traffic management systems are being developed. And the argument is this: the alternative, an AI compute shortage that slows scientific and medical progress, carries its own enormous costs. But those responses are not yet proven at the scale being proposed. And that gap between ambition and proven safety is where the real debate lives. Who owns the sky? So, what does all of this actually mean? If you're an investor, this is the clearest signal yet that the infrastructure layer of AI is the next great frontier. Not the models, not the apps, the physical compute. And the next battlefield for that compute may not be on Earth at all. If you're a technologist or researcher, this is a challenge and an opportunity simultaneously. The engineering problems of orbital compute, radiation hardening, thermal management, latency, debris avoidance are genuinely hard. They will create entire new fields of expertise. And if you're a citizen of Earth, which presumably you are, this is a moment to pay attention. Because the decisions being made right now about who builds this infrastructure, who regulates it, and who benefits from it will shape the trajectory of artificial intelligence for the next 50 years. Nokia didn't lose because they made bad phones. They lost because they didn't see that the phone was becoming a platform, and they let someone else own that platform. The question Elon Musk is forcing every government, every tech company, and every investor to answer right now is, who owns the sky? Whether his plan succeeds or fails, that question isn't going away. If this kind of analysis is what you come here for, hitting the like button really helps this channel grow. And I want to hear from you. Do you believe AI compute belongs in orbit, or is this the most expensive distraction in the history of technology? Drop your answer in the comments. Subscribe if you haven't yet, because we are just getting started. Thanks for watching.